Is it? Well, it's too late. It's too late. Next time. Yeah. James.
So if we are sick and we have to miss class for some reason, are lectures on Canvas?
No, they're not on Canvas because they're too big. I have a YouTube channel that I stick them on. As silly as that sounds, but you need to let me know beforehand.
Oh, yeah.
And then I try and record them and I stick them on a YouTube just because otherwise they get put on the Canvas homepage and they're huge and they're a real pain in the butt to deal with on Canvas unless someone knows a better way and I just haven't found it. Yeah. So the better way is I send you a YouTube page.
Channel on Canvas?
What? What? No, it's not. So in this case, I see what you're asking. For like to go back and watch these, like I just said.
Yeah, like if I'm sick or something.
Fair. I will figure out a way to deal with that. Yeah, for the most part. It takes forever to download. Okay, does everyone understand what we've got so far? Right, and then what do? I populate first. I leave next as null. Now I create a second int list. My original pointer is from list 2 over here. But then look at that next line. I'm going to populate first here. Right, so now I give this a value. And then I go back and I say list.next equals what?
Oh, first.
Equals list 2. So the pointer, boom, boom, next becomes this. What do I have here? I do have a pointer. I do have this silly pointer that I'd love to get rid of. Okay? But that's okay. I have first, and the next value, the next node is, this has got a value, and this next node is null. If I wanted to add something new, what would I do? I do list 3, and I could keep constructing. Is this a really, so I've now, all I've got is this, but I've created a way to create lists, right? Yeah. Is it an efficient way to create lists? No, it is not. Okay, so we're going to disconnect. We're going to come back here. What I'd like you to do is think about what the next step would be to make this simpler. Okay, so let's say I didn't do that. I create the new list and then just run that. Let's check it out and see. Alex, it's a good question. And if I go to Visualizer and I start stepping through this thing, it's going to be null regardless, right? And I get that structure. So it works the same. Is there another way to get rid of this list 2 pointer? I think of a way to get rid of this list 2. What if I didn't do... Okay, so instead of saying list.next equals null, what could I say there? Oh, I could say list.next equals new int list. Now I have a slight problem there. Yeah, so I could do something like this instead. What I could do is instead of building it this way, I could say list.next equals null, right? And then I could say, because if I think about what next is, let's just debug this thing one more time and look at it, okay? And I go to like this. Whoops, I dropped that value entirely. What's the next, if I want this pointer to go to something next, right? Well, this is what? It's actually list.next .first equals 4. What happens if I do that? Get that? Oh, didn't like that. Now list.next needs to be an int list, right? So I could do this though. I could do list.next equals new int list. List.next.first equals 4. List.next dot,
First stop. First.
no, not quite. List.next. Think about the structure. I know this is confusing. List.next. Well, let's comment that out for just a second. Dot next. You got it. Dot next equals what? Every time I create a next, I have to do what is the next thing? New int list. List.next.next.first equals 5. Whew, okay. And then when we visualize this thing, step into it. First equals 0, right? Create the new thing. I get 3. Dot next. Oh, there we go. 4, 5. Oops. I want to go back and do that one more time. There we go. Look at that. We've got a really nice int list going on, right? How many times are you going to want to say, like when you get to the 100th thing, it's going to be list.next. Sure. It's an infinite line, essentially. Okay? Does this make sense, though? Just like theoretically, right? Because each time I'm making a new node, I'm making a new int list, and then I'm just saying I'm making that pointer next. Okay, so now make it cleaner. How do we make that cleaner? Because this is ugly, let's be honest.
Make a method.
Yes, specifically, what would be the, like, right thinking, what would be the first thing we do? Not yet. No, you guys said it beforehand. What's the if we were writing a class, what would be the next thing we do normally in writing a class? A constructor. So what would our constructor be? Public int list. And do we want to pass in parameters? To make our life easier? Yes, we do. What do we want to pass into this thing? Yeah, so we're going to pass in int f, int list n. Finish that out. And then go ahead and use this structure to try to create this list. How about it? You can do it together, but you're going to try and create 3, 4, 5. We'll just make it pretty long. What's up? What did I do? Oh, I'm throwing in random symbols, aren't I? It was a really long weekend. Try to go down here. You can get rid of all this, okay? Because this isn't useful anymore. I just want to make sure we understand all this. Are there any questions about this before I get rid of it? Does this make sense to everyone? For each thing, I'm giving it a value, and then each next has to be a new int list, and then I'm just chaining them together by using this next terminology. Yes?
Chaining the next technically recursive? Because you're calling it.
No, it's not. It's iterative. It's just a really weird structure you'll never see because it's a silly way to do it. But we're building. We're gonna get rid of that. Let's spell the word first.
Or just making a constructor.
Nope. You're going to go down into your main method and try to use your visualizer and some structure here to create the list 3, 4, 5. Because you're passing in, yeah, you can't pass it. Next can't be an int. It has to be an int list. So your first one, what is it? Think about what. Well, that's first. But what's your first int list? Or the next be int list of size bit. So you got to think about this a little bit structurally, because if I have this, think about an int list start with like remember, decomposition. Start with an int list of 1. What's first here? If I were using this as an int list of 1, what's first? 3. What's next?
Nothing.
Nothing. Nothing?
No.
No. So when you create your first int list, next is going to be null. Right? So I'm going to say int list equals new int list. I have to pass in parameters 3, comma null. And if I do that and I debug this thing, I should come over here and look, and it should just give me my nice new int list. Right? But I want you to show me in your visualizer 3, 4, 5 linked together. Anyone coming up with a linked structured list? Feel free to, if you get something to share, I'll be right back.
The word next is like lost meaning. Whoa, okay.
Anyone get something that works? Okay, so let's look at this thing together. Let's first go, actually no, you gotta wait for me for a second here. Ba-ba-bum. Okay, so we could do the exact same sort of thing that we did a minute ago, which is we've got this, right? And then I will tell you that in this class specifically, I highly recommend you have a notebook, because drawing out your structures is going to be really key. Right now I have this, I have a value, right? And then I have next equals what? No. What is this? What am I calling this thing right now? That's this. What's this? Not quite. List. This thing is a whole structured list. This is list dot first, right? And then to create for over here, what can I do? List dot next. No, this way. No, this time I'm not going to do that. Equals new int list for comma null list. What? Dot next equals new int list 5 comma null. See if that works, first of all, right? I've still got my little red dot in there. We're going to debug this thing. We're going to put it runs. Cool. Come over here. I get that. I get that. I get that. Okay? There is another way to do this, which is, does that make sense?
Yeah.
Still, I mean, is it better than what we had before? Not really, right? So there's another way of doing this, which is chaining it backwards. Building the thing backwards. So why would we build it backwards? Well, the reason we build it backwards is because if I get rid of these two lines, and I come up here and we'll put 5 first, right? Because then I can simply do what? Instead of adding this way, I can say this is 5, right? Well, I can actually just use list, believe it or not. I can say list equals new int list. What's my next value? 4. And this gets recursive now, Daniel, because what's my next going to be? List. And then list equals new int list 3 comma list. Oh, are our brains popping yet? See if that works. So we get 5 and null. We created that thing first. And then we say, well, no. List is going to be a new int list that has 4 as its first value, and it's going to connect to list. Wait, what? Boom. Boom. That one's a slightly harder conceptual leap. Yep. So again, I'm saying I create a new list here. List equals new int list, 5 null. We got that, right? That's just that structure. Then I say, okay, list is actually going to point to a new int list. It's going to have 4 as a value, and its next is actually going to be that original list thing that I had. Bam. Because remember, list in this case is just a pointer to the first thing in the chain.
Did we do an exercise like this at AP?
Probably. Not quite like this, because this is rather confusing, but probably something like it. Right? And then again, I reassign list to a new int list. I'm giving it the value 3, and I'm chaining it to the existing list. And I get that.
And since we assign list to the new value, that goes back to the previous one, not the one before that one.
Sorry. This is really confusing, so I don't even follow your question. What do you mean?
Like, since every time we list equals new int list,
Yep.
and then we recursively have list,
Yep.
we're pointing back to the same list that we just called earlier.
We're pointing back to the list we created in the first place. Yep. So we're just reassigning the variable, right? We're creating a new int list, and then this existing list is what my next would be. Okay. So we're creating the list backwards. Yes? Cool. All right. There is another way to do this. Do we even hazard a way to do this? Which is sort of simpler. Okay, ready for this one? Can anyone think of one more way to do this? And we already did it. So we're going to start with 3. And what do we want next to be? If we start with 3, what should next be? A new int list. With what?
With
4. And what's its next going to be? New int list. 5. I have to give its next a value. Null. And we're done. That's sort of easier and maybe more intuitive, but they're just chained inside of each other. Right? So now I come in here. Why did it do? Oh, because it's one line. I can't break it down, right? Boom, I get the whole structure just like that. And you can do this. You can pass in objects. You can create new objects inside of instantiation. And this is, again, in my mind, this is simpler than chaining it backwards with the reuse of the variable list.
Could you just run the design?
All good. So this is it. We've got 2 instance variables, we've got a constructor, and we've just created lists. And we've seen how to do it in the main method a couple of different ways. Now, we are missing something here, right? Because obviously, is this the most efficient way to create chain things? It's not, right? What type of a method would we probably want, Donald? Well, like instead of doing this, what method would I want that you can use with a real list, an array list? What methods can I use with an array list that would be nice to be able to do this? Add, like an add method, right? So I can just add 3, add 4, add 5, right? That would be the next step. Right. But we need to be able to do something first. So there's one method that we need before we move on that's really important. Anyone guess what it is? ToString would be helpful for printing this thing, but we have the visualizer, so we're not going to worry about that just yet. What do you mean a set? Well, what's the problem with lists? Not contiguous. Right? And what do I know about an array? Fixed size. Size is going to be really important for us. We'll find out. So public int size. We want to be able to know the size of this thing. Because with the size, I can do a whole bunch of different things. Well, first of all, what does it allow me to do? I can iterate it through it easier. It's going to allow me to know how much is in there. If I want to add to the end, I need to know how big the size is to add to the end of this thing, unless I'm always adding to the front. So size is going to be really important. Now here's the trick. You ready for this? We're going to do size recursively. Okay? So we're going to, again, stretch your brain a little bit. Okay? So this, we're going to put in a little doc string here. Returns the size of the list recursively. Okay. I told you this class was going to be easy on homework and hard conceptually. Okay, so I'm following through on that right now with our first structure. So how do we get size? If I said it's recursive, okay, how do I get size? Again, I highly recommend that we decompose it and we think small and build from there. So what do I need for a recursive method? 2 things for a recursive method.
Oh, the base and the return. Yeah. If condition.
What do you mean if? Do I have to have a condition?
You need a return. A recursive call.
I need a recursive call. There we go. Oh. So usually this will be an if statement, right? And my base case is almost always an if statement. Oh, silly me. There we go. So I got a base case and my recursive call. Okay? What's my base case?
Size of the first list.
Size of a list of size what? 1. No, it's just this size of 1. This will be my base case. Okay? So what is my if statement going to be in that case?
If the list dot size equals 1.
I can't use I can't have a recursive call in the base case.
If a list dot next equals null.
Bam! If next is null, this will also get me to the end of a list. So if, and I can't say list. Nope. Think hard. Something dot list. Sorry, it's something dot next equals null. If that thing is null, what do I return? How big is it?
1.
Return 1. What dot next?
If list dot size.
We don't have list here. It's a method. There's no list in here. You can't call IntList inside of the class, but we can with a specific word. How inside of this class?
Hash it in.
No. How do I? It's simple, right? Inside of this thing. What? What?
This.
To refer to refer to an object inside of a class. This. So now we're going to see the word this a little bit more often than we did in. So if this dot next equals null equals null, return 1. Now, what's my recursive call then?
Like this dot first. Wait, you counted backwards.
I'm counting backwards now. So now if I have 3 things, right? When I get to this, is this dot next equal null?
No.
No. Is this dot next equal null?
No.
Is this dot next equal null? Yes. So I, in that case, return 1. How do I get back? Yeah.
Plus
Call it back.
Yeah. How do I call it back? Return what?
this dot next dot size.
This dot, yes, you got it. It's return 1 plus this dot next dot size. Now let's see if this works. So down here we've got this list, and we'll call list dot size. What should we get?
3.
And we'll print it. We should get 3. And I'm just going to run it now. I'm not going to, I got 3. Does that recursion make sense? Right? If this dot next equals null, so if I have one thing, I'm going to return 1. Otherwise, if I think about the recursive calls here, and here, let's go ahead and debug it. We'll come back in and debug it. If I go to Visualizer, the way we're going to do this debugging is we're going to step over. We create the list. Boom. And then here, we're going to step into, because otherwise we're not going to see it. So Alex, look, everyone's eyes up here for a second, okay?
I'm having problems with my thing.
I'll help you in a second. But I want you to see this, because otherwise I'm going to have to reteach it again. So we step over to get to this, then you step into it in your debugger, because that'll allow me to go into size, step into it. If this dot next equals null, is this dot next equal null?
No.
Nope. So I return 1 plus this dot next plus size. What am I returning? Well, I go to this dot next dot size. There you go. Yep. So, well, no, it's going to return 1, but it goes to this dot next dot size. When I call this dot next dot size, right, I'm going to go back up to this. Oops, step back into. I screwed it up. Yep. It creates a recursive call stack, so I can step there, then I have to keep stepping into step into size. So we know that this dot next is not null. So I come down here, I call return 1 plus this dot next dot size. When I call this one, it goes back up here. This dot next equal null?
No.
Not yet. Nope. So I come back over here, right? Sorry, I go down here. I call this return 1 plus this dot next dot size. This dot next dot size. I call this. Is that null? Yes. I return 1. Okay. Oops. But I also have those other ones. 1 plus 1. Yep. And I get the 3. But my visualizer is not being very clean here. And there's my console. Yep. Kind of cool, huh? And this is where recursion is, like we talk about recursion, it's kind of a fun party trick for the most part in AP. Like it's not very useful. It will be incredibly useful in this class. So it can be really tricky, but we really need to wrap our heads around recursion and be able to do that. We can also do, and this is your homework for tonight. Ready for this? This is, we're going to do another method. It's going to say public int iterative size. Okay, and for this one, you're going to return the size of the list iteratively.
So we can't use a recursive method.
Can't use a recursive method in this one. You're trying to do this iteratively. It's possible, and some people might like the iterative size more, but I think that this recursive size method right here is just super clean and nice. Right? If you can wrap your head around it, it's a really clean way of getting size recursively with an IntList. Cool? So that's your homework tonight. So, and it'll read a little bit differently. And then next class, we're going to add a get method. So what would get allow us to do? You got it. Because that would be, if we go look at, if we think about the methods that we'd want out of, what's that? Center? A setter, yeah. What do you mean by, sorry, what do you mean by a setter? Oh, to go put a random thing in the middle? You can. We're not even close to that yet, because we'd have to think about a whole bunch of different things. But if we go down to methods here, inside an array list add, that would be really nice. We could add it an index. Clear, clone, you don't have to worry about those. Contains would be nice. What are we going to have to do to do contains? Contains is pretty straightforward, actually. Yep. Get. So this is what we're going to add next class. Remove, we're not there yet. We're not going to worry about that. Size, important. And then we're not going to worry about the rest of those. I will tell you that by the time we're done, ready for this? I'm going to open up my other int list. How many lines of code do you think my int list is from last semester? We add a few more methods. What's that, Danny?
You do the same exact thing.
I did the same thing here, but then we added methods. 300 lines of code. Our int list is going to be fairly extensive by the time we get done with it. Okay? But for tonight, you're going to try to add iterative size. And then next class, we'll start with our get method and work from there. Yeah, Danny?
Do we need to submit our iterative size to Canvas, or do we just?
Yeah, so I'll give a submission box where you can just copy and paste the code into Canvas.
Just the method.
Just the method. You don't have to do anything else. Just copy and paste the method into Canvas. Other questions? Awesome. Do not use AI. Have an awesome rest of your day, and I will see you all. So we'll get things like skipify and reverse destructive, and we get all sorts of fun methods in here. Evens, shift, reverse the list. That's a good one. Yep. Oh, yeah. Let me look. Yeah, please push in your chairs. Have an awesome rest of your day. What line is expecting something? I'm expecting something on line 29. So scroll down. You just don't have it. You got click on that filter, see what's matched to. Oops, that's your main method. Click on that one. So that's all right.
And just for help.
Yep, have a good one. Go through. Oh, you have this. I mean, it's not like the fact that you have. Was it working before you put in iterative size?
No.
Okay. So you got to copy out iterative size. It's not going to let you get the method in there. You copy out the. All right. Run it again. Let's see what. Tells us now.
Oh. Wait, no.
No, that's fine. Let's see. Wait, public. Int.
Oh, it was not like that before.
This dot first equals first. Start going through your filters because there's something in there that's not working.
Just delete it.
Yeah, get rid of it. Try it again. You got stuff extra. Alright, comment out your that print line. Just about it. Okay, comment out the still on line 29. You don't have one. Yep. Okay, thanks.
Yeah.
Why do I feel like it's something up here? First, what's next? IntList. Size. Was it working before your size method?
It never worked.
It never worked. Okay, so it's down here. List equals new int, list 3, new int, list 4, new int, list 5.
It only worked in the very beginning. When we were just doing the basic stuff. It worked for the first dot. Next dot. Next.
Huh. What did you do?
I have no idea.
So it doesn't like your public int list. It's something with your constructor doesn't like.
Yeah.
Oh.
Oh my god. Did I actually do that?
I think so. Run it and just make sure that's all it is.